Hello, assalamu alaikum everyone. Welcome to my brand new video. Today I am gonna tell you about how you will calculate a unit root test for panel data and how you will interpret the result. I will try to tell you step by step so that you can understand it properly. So let's get started. First of all, you can see that there is a data set which is a panel data. There is country, basically there are 35 country, the year from 2010 to 2018, and there is GDP data, import data and export data. So first of all, we need to declare the data set that it's a panel data. So we need to go to statistics, then we need to go to longitudinal or panel data, then setup and utilities, declare dataset as panel data, then panel ID is country and the time variable is year. So you need to set that. Then there is yearly data, then you have to click on submit. Then you can see that this data set is panel data, it has been declared. So after that you need to go to statistics, then longitudinal or panel data, then unit root test, you need to click on that. After that you can see that there are 6 types of unit root test. So we'll go on by on. First of all, we'll see Leveling-2 test. So in that case, we need to select the variable. Then we'll select GDP. Then we can hypothetically select that lag specification, that is on. After that, here you can see that panel setting. As we have already declared the data set as panel data, that's why we don't need to do anything here. But if we don't do that before, then we need to set the panel ID and time variable from this place. Then you have to click on submit. You will see that there is null hypothesis is panels contain unit roots, and the alternative hypothesis is panels are stationary. Here we can see that p value which is on, that means the p value is greater than 0.10. that means we cannot reject the null hypothesis, so we have to accept the null hypothesis. That means panels contains unit root. As we can see that this GDP data is not stationary at level, so now we need to look at that if it is stationary at first difference or not. In that case, you need to write gen space, you need to give a new name of first differences of GDP, that I am giving D GDP, then equal to, then D dot means the first difference dot the variable's name is GDP. So you should not give any space between them. So then click on enter. You can see that a new variable has been created, that is first difference of GDP, this one D GDP. So now we need to run again the root test for first difference of GDP, and we need to see if it is stationary or not. Then submit. Here we can see that p value is 0.00. that means it is significant at 1% level. That means we need to accept the alternative hypothesis, as the p value is less than on 0, and it is significant at 1% level, so we need to accept the alternative hypothesis, that is panels are stationary. Level Lin 2 test, we can see that the GDP data is not stationary at level, but it is stationary at phase difference. Another kinds of test we can run, that is Harris-Travellis test. So in that case, here we need to again select GDP. Then we can select any one of them. At this time, I'll select include time trend, or you may not. So then submit. You can see that the data, GDP data in this Harris-Travellis test, the p-value is on, that means it's greater than 0.10. That means we cannot reject the null hypothesis. So we need to accept the null hypothesis, that means panels contain unit root. So in this case, we need to see that if it is stationary at phase difference or not. So in that case, if we again run the test in DGDP, we can see that yes, it is stationary at phase difference, as the p-value is less than 0.10. That means it's significant at 1% level, so we can accept the alternative hypothesis, that means panels are stationary. Now another kinds of test we can run, that is this one. We can select here another variable like import data. We want to see if it is stationary at level or not. In this case, we need to at this time we'll select include time trend, then submit. Here we can see that the null hypothesis is panels contain unit root, and the alternative hypothesis is panels are stationary. As the p-value is greater than 0.10, that means we can accept the null hypothesis. So the null hypothesis is panels contain unit root. So in this case, we again need to run we need to see if it is stationary at phase difference or not, as it is not stationary at level. So in this case, we need to again create a new variable of phase difference of import. So in this case, again gen, we need to give a new name, d import. You can give any kinds of name, equal to then d dot import the existing variable's name, that is import. So then you need to click on enter. Here we will see that again a new variable has been created, that is phase difference of import data. So in this case, we need to again run that if it is stationary at phase difference or not, as it is not stationary at level. Here you can see yes, it is stationary at phase difference, as we can see that the p-value is less than 0.10. That means we can accept the alternative hypothesis, that is panels are stationary. So here we can again see that this import data is according to this method is not stationary at level, but it is stationary at phase difference. Then if we run another kinds of test, that is impersonation test. In that case, import data, we need to select import. If it is stationary at level or not, we need to see that. Then again submit. We can see that p value is less than 0.10. That means here you can see that all panels contain unit root, that is null hypothesis and alternative hypothesis. Some panels are stationary. As the p value is less than 0.10, so we can accept the alternative hypothesis, that means some panels are stationary. So according to IPS method, the import data is stationary at level, so we don't need to run the first difference data in this case, as it is already stationary at level. So, and it is stationary at 1% level. Then if we run another kinds of test, here is Fisher type test. Again the import data, we can see that here we need to see or look at this data, inverse chi-squared. So here we can see that panel data is 0.00. That means it is less than 0.10 and it is stationary at 1% level. So we can accept the alternative hypothesis, that is at least one panel is stationary. That means according to Fisher unit root test, the import data is stationary at level. Again, if we run another kinds of test, that is Henry LM stationarity test, on import data we can see that p value is less than 0.10. So here you can see that the null hypothesis is all panels are stationary, and the alternative hypothesis is some panels contains unit root. This 100 unit root test is basically different from the other kinds of unit root test, as the null hypothesis and the alternative hypothesis is opposite. Other kinds of test we have seen that the null hypothesis are that all panel contains unit root test, and the alternative hypothesis is panels is stationary. But in Henry unit root test, we can see that null hypothesis is opposite. That means all panels are stationary, and the alternative hypothesis is some panels contain unit root test. So as we can see that p value is 0.01, that means it's less than 0.10. So we need to accept the alternative hypothesis and we need to reject the null hypothesis. So if we accept the alternative hypothesis, that is some panels contain unit root. So according to this Henry unit root, the import data is not stationary at level. So again we need to run on first difference, that means if it is stationary at first difference or not. Here you can see D import, then submit. Here we can see that the p value is greater than 0.10. That means we have to accept the null hypothesis. The null hypothesis is all panels are stationary. So here we can see that this import data is stationary at first difference according to Henry unit root test. These are all 6 panel unit root test in STATA, and in this way you can interpret the result and represent it in your paper. These are all about panel unit root test. Hope you will like it. If you like this video, please like, share and subscribe my channel. Allah Hafiz.